All right, what's going on? What's going on? Today, my task is to talk to you guys about chapters 11. And today we're going to be talking about hypothesis testing from variances as opposed to means. Before we were looking at the averages, the means, and now we're going to transition from the means to the variance. Please understand that hypothesis testing will still use the same concept. If in the alternative is less than, it'll be a left tail test. If in the alternative, the claim, the statement shows up in the alternative is greater than, it's a right tail test. If the alternative is equal to, not equals to, it's a two-tailed test. But for the most part, when we're dealing with a test for variance, it is a right-tailed test. On very few occasions, it could be a left tail or a two-tailed test, but for the most part, it is a right-tailed test. So in your mind's eye, you can start there. Some of you guys are wondering, why are we doing variance as opposed to mean? Let me give you a quick example. If I'm a baseball pitcher and I average, this is the mean, 95 miles per hour, you'd be like, yo, man, you're doing great. But the next question is how accurate are you with that 95-mile-per-hour pitch? Are you within the strike zone or are you not? The variance tells us the spreadness of our data. In this example, the spreadness of our pitches. Am I pitching this 95-mile-per-hour pitch within the strike zone that we're setting or we want it to be, right? And the variance helps us to do just that. It tells us, is this pitcher's variation within the standard or not? If it's not within the standard, for example, let's say it's not the status quo, you would reject it. You now have the ability to act and say, hey, we need you within this zone or this variance level that we have set. So with variance and test and hypothesis, you help make informed decisions by determining, are you within the standard or are you not? If you're not, you can make different recommendations based on the standards that you want to see. So today, that is exactly what I want to talk to you all about. So I'm going to share my screen with you all. And we're going to get into the homework assignment, and we're going to actually do some tricks and tips within Excel to get this understanding of variances. So we're going to be using a chi-squared distribution to help us understand this concept, but it follows the same principle as hypothesis testing. All right, so if you guys can, please go into your scroll down, find your class resources. Please download chapters 11. Do I see it right here? Chapters 11, Excel's template. Open up Cengage as well. Click on view and let's get into it. So I got my Cengage right here. I'm going to open this up. I'm going to give you some tips and tricks. I'm going to show you a couple of them. Then you guys get to go ahead and knock these out. Don't forget, with variances, we're not only doing one-tail variance, we're doing both one-tail and two-tail variances. So we're going to plug in our information. And for the most part, it is a right-tailed, upper-tailed test. All right, so keep that in mind. What I'm going to do is I'm going to slide this over to the right. I'm going to get my Excel up like this. Can we please start off with 11.01? And what we're going to do here is we're going to be using this distribution table right here to determine what the critical boundaries are, if I can put it that way. All right, so don't forget, for the most part, this is a right-tail test. So we're going to be looking at this chi-squared type table to determine what is the value right up in here that separates the status quo from what is not the status quo. All right, so let's get this going. And we're going to start off with 11.01. Bam. So the way they actually lay this out, chi-squared, chi-squared, however you enunciate this, is they provide you x squared, and then they give you your alpha value. Once they have given you the alpha value, then they also give you your degrees of freedom. So you're looking at the alpha value. It will show up on the table on the top, right up here. And then what you're looking at is the degrees of freedom on the left. So you go to the left, and on the top and where they intersect, that will be your chi squared or chi squared value, the border that separates what is the status quo from what is not. All right, so on this first one, we're looking at the degrees of freedom of 5. So we scroll down until we get to 5. All right, 5 at 0.05. If I scroll over one more, 0.05 is this number right here. And just so we can check it, just to see 3 decimal places, is going to be 11.070. Let's check our work just to make sure we got that right. Correct. All right, I'm going to do just one more as an example. Please take your time on this and knock it out. I'm going to do the very last one. All right, so we got x squared at 0.95. 0.95. So normally what I do is I take my mouse, grab the 0.95 that I'm going to, and then use my mouse to scroll down. So I'm keeping it on that 0.95, and I'm looking for 18. So right here, 9.39. I can put in the 0, but it should work. Bam. All right, so take your time, fill those out. You can also use your Excel and put those numbers in here. All right, so you know what your answers are. Some of you guys are high speed. You guys can actually calculate these using an Excel function. See if you can figure it out. But on this example, what we want you to be aware of is that there's an actual table out there that you can actually go find your degrees of freedom, which most likely is n minus 1, your sample size minus 1. That's how you get your degrees of freedom. Find your alpha value, and then where they line up, where they intersect, that will be that critical boundary. Let's go, let's go, let's go. All right, so can we go over to 11.07, please? All right, bam. All right, so in this one right here, we're gonna be given data, and we're gonna actually calculate the sample size, we're gonna calculate the mean and all of that stuff. So we're gonna enter our data right here, calculate all of this, and get our answers rocking and rolling. So let me go back, slide this back over here, and I'm gonna move this over so I can see it. Remember, junk in equals junk out. So I'm just gonna highlight it all, copy it, Control C, Command C, and in this first box, I'm just gonna click it, single click, and paste. Bam, I got all my data right in there. So then the question is, what is my count? So I'm just gonna grab this formula right here, copy it, paste it right in here, all right? And I'm just gonna maximize this so you guys can see this a little better. If I double click on my range, I can grab all my values, all of them, all right? And press enter, and it tells me, hey man, I got a count of 16. Perfect. How do you find the mean? The average. By now, hopefully you guys are fast on this. You just keep rolling, grab it all, bam, bam. Variance, var.s, grab it, range of all of it, enter, and then what is my standard deviation? Copy, paste that in there. It's actually the square root of your variance. S caret 2 is your variance. So if you highlight S caret 2, then you can click on your variance's number. All right, just like that, and press enter, and you will have everything that you need. All right, what is your hypothesized value? Let's look. All right, in this example, it looks like 16, Americans spent a record high 9.1 million on Halloween purchases. All right, sample data shows an amount in dollars, 16. All right, now Halloween nut. What is the population mean? What is the estimate of the population mean among adults? All right. In this example, give me a second here. I'm looking for my hypothesized value. All right. Let me see. So it's going to ask, what is the mean? What is the sample standard deviation? And actually, I don't think I need it. What is my lower and upper tail? All right, so since this is we're gonna make the assumption this is a right tail test, I think they are looking at this value right here. Let's test it out. All right, so it's always good to find out or figure out what exactly is Cengage asking. So on here, 42.6, let's check my work just to make sure I got my data right, good. All right, so you guys can get your standard deviation, lower and upper limits. I'm just making the assumption, because I didn't read through all of this, that this is going to be a right tail test. All right, it's either going to be right tail or two tail. All right, so I'm just going to put my lower limit as that, and they want 2 decimal places. Actually, it's way down here, sorry. Okay, my lower and upper limits are way down here. All right, got it. So 17.05 and 35.72. Check your work. Bam and bam. All right, perfect. If they had wanted the confidence interval values, then you would have used these right here. But what they want is your X1 and your X2 value, X1 and X2, and those are the values right there that you would enter. All right, let's move on to 11.09, please. All right, 11.09, here is the information right here. So I know for the most part, that most of these variances are a right-tailed test. So I'm not even gonna read through this, all right? But I'm sure if you read through this, it's gonna give you a hint that this is a right-tailed test. But let's see. So if it's right-tailed, it's gonna be greater than this value right here. Let's check our work just to make sure, because I want you guys to get into the mindset. Do you see greater than or a right tail test? All right, so here is our hypothesized value, 0.0004. So you guys can actually come in here and type it in. Let me make sure I got it all right. All right, so you can actually type in 0.0004. Plug in your number, please, whatever shows up as your hypothesized value. All right, this is a right tail test. So you can actually double click in here and make this like a different color. All right, I'm just gonna make this red, so I know it's a right tail test. All right, what else do they give us? The sample size, suppose the sample of 30, plug in whatever sample size you may have. The mean, in some cases, they don't provide you the mean, so you just leave it blank. Let's look, do we see a mean in there? I don't see a mean. All right, so we're gonna leave that blank. What is my variance? In this example, S squared represents our variance, 0.0005. And just like in hypothesis testing, what are we comparing? This 0.005 and the hypothesized value, 0.0004. All right, automatically your standard or your sample standard deviation should be updated. It's the square root of this number right here. All right, so just What is the null hypothesis? Remember, it's the opposite and it always has an equals to sign. So if this is greater than in the alternative, this should be less than or equals to. So it should be less than or equals to that. All right. What is my test statistic? If I scroll down, I will see what my test statistic is. I know it's going to be hard for you guys to see it on your end. All right. But I'm just going to plug in the numbers that I have. You guys can then calculate your p-value. Then you can answer these questions. Do not reject. You see, it says do not reject. So it's going to be do not reject. And then you can answer this last one based on a do not reject. Please read this so you can get the business idea and how it actually works in a real business. And then you can apply it. But I'm just going to check my work just to make sure I'm leading you in the right way. Bam, 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 and bam. Let's go. So variance should be pretty easy once you get the concept of hypothesis testing. All right. The alternative hypothesis for the most part is going to be greater than. All right. Unless they tell you otherwise. All right. Let's go to 11.17. All right. And this one, as you can see right off the bat here, this is a two sample test for variance, hypothesis test for variance, two samples. So this is 11.17. Let's find that. My clicks are way off today. All right, 1719. All right. All right, here we go, here we go, here we go. Ooh, look at that. So there's 11.017 and then there's 11.17. All right, so we'll get this one next. All right, so that's a 5. Okay, here we go, here we go, here we go. All right, so you're going to have to read through this. Find your sample size for the first variance. Find the sample size for the second variance. This is a two sample test. So we are assuming that one is greater than the other. All right, so let's start right there. For my alternative hypothesis, I'm just going to assume that this is a right tail test. Variance 1 is greater than, or yes, variance 1 is greater than variance 2. So it's greater than variance 2. Just check your work just to make sure you're good there. Bam. All right. So if this one is greater, you should know what the null hypothesis is. So then enter what you got. A sample of 26 automobiles. So that's where you put in sample 126. All right. Show the sample standard deviation for annual repair. A sample standard deviation of 190. All right. Make sure you're putting it into the correct spot. And automatically your variance is going to be updated for you. All right. Now the next one, 25 automobiles. All right. With a sample standard deviation of 100. All right. So we got these two variances right here. We're going to check to see if this one is greater than this one. All right, so you can look at the numbers and kind of tell if one is greater than the next, but is it statistically greater? So my hypothesized value, if it's a two-tailed test, is 0. Don't forget that. For the most part, it is 0. So therefore, what is my test statistics? You scroll down. Do you see how it says F-stat? When we're dealing with variance, the test statistic is an F-stat value. And for the most part, that's a right tail test. So in my case, it'll be 3.61. And for right tail, it will be rejected. All right. So I'm going to scroll down. You guys can fill out the rest. Your p-value for a right tail test. Find your p-value for the upper tail right down here. Plug it in, and you should be good to go. Excellent. All right, so let's go to this multiple choice right here. 11-017. So let me find that. All right, that was right down here. Perfect. We are interested in testing to see if the variance of a population is less than 7. This is the population's the standard deviation, or if the variance of a population is less than 7. The correct null hypothesis. All right, so this one is a poorly written one. All right, this should really be saying the population standard deviation is less than 7. All right, and remember, the claim, the statement shows up in the alternative hypothesis. So if the alternative hypothesis is less than 7, if the population standard deviation is less than 7, when the null variance be the squared of that, the squared of 7 is 49. So I'm assuming they're saying that. All right. So once again, they should have said if the variance of a population standard deviation is less than 7. All right, so I just want to make sure I clarify what exactly they're saying here. So make sure you check it off correctly on yours. If you don't have the ability to check this checkbox, remember, you can, if you can't see it, just double click between A and B, tricks and tips, spread it out, double click it. All right, I guess just drag it over so you can see it, and then change the color to red so you know that's the correct answer. Now, once again, make these Excel do what it do for you. If you want to type in there, instead of population, you can put in population standard deviation. All right, so that way it makes more sense to you. You got to make these Excel templates do what it do, make it do what it do for you. All right, good work, good work. Let's move on. Let's go to 11.19, please. Thought I saw that like right down here. Perfect. All right, you guys are going to get the data set. Everyone has the same problem. The data set shows up right here. So I'm just going to maximize this. All right, and we're going to conduct an F test of all of this information. And just within a couple seconds, we'll be able to get our answers right here. But I'm also going to show you how to do it manually. So if these numbers were to be updated, this would automatically be updated. But your F test, if you use the data analysis toolkit, will not be. So that's why it's important to probably have both processes down pat. The one that is manually calculated, so if these numbers do change, this will automatically update, and the one that you can actually do really fast and easy. So what I'm going to do is the really fast and easy one. Then I'm going to show you how to make these calculations right here. All right, so let's start off right here. So here is our data set. All right, we got a whole bunch of, we got machine 1 and we got machine 2. And we're checking to see these variances between these two samples. So what you do is go to data, data analysis, all right, and look for F test to sample for variance. F test to sample for variance. You guys should be able to see it right down there. All right, click on OK. All right, so what is your variable 1? Click in there and then select from machine 1 all the way down. All right, you see there's more data under machine 1. Then you can click on variable 2, go to the very top, machine 2, all the way down to your last number. All right, so the first one is A1 to A26. The second one is B1 to B23. Make sure you select labels because we selected label in our first row. All right, the output, we're going to click in this box right here, and we're going to put the output right at this yellow box right up here. All right, so I can move it over. All right, so you guys can see right up here, we're going to put our output at I1. All right, so within a couple seconds, you press OK, splacker. You already have all the stuff that you need right here. All right. So what I'm going to do is zoom in so you can actually see what the output shows. Automatically, it calculates the mean for both of your machine 1 and machine 2. It calculates your variance for both machine 1 and machine 2. How many observations in machine 1 and machine 2? You scroll down, it gives you your degrees of freedom, n-1, n-1, and that's how you got 21. It gives you an F-test. All right, so if this is a right-tailed test, all right, and for the most part, this is going to only give you a one-tailed value, a right-tailed value. All right, the question is, if 2.05 is your critical boundary, where does 8.28 fall? Hopefully, to your mind's eye, you're saying way out there to the right. If this is a right-tailed test, if the rejection zone is in the right, hopefully with this data, you can say, yo, man, we are rejecting this. We are rejecting that machine 1, I guess, in this example, let me see, what exactly are they saying? They don't really ask, or what is the conclusion? Machine 1 is greater than machine 2. You would reject that. Nah, it is not. All right. So let me also show you guys how to do this manually. All right. So here it is. It's the count. Once again, this is the long way, but it is the most reliable way. So you paste your formula in there, grab it, and we're going to go over to machine 1, just the numbers, all the way down. Press enter. All right, go to this one, paste it in there again. Now this is for machine 2, all the way down. Perfect. This one here, we can find the average. And do you see how quickly Excel was able to do that for you? If you did the F-test, all right? So there are benefits to using either or. Just use the one that is best suited for you, all right? I would say get both of them rolling. So when you update this one to the left, this one will automatically update right here. All right, and last but not least, we'll do our variance. Copy that, paste that. All of it. All right, you can see the formulas up here. All right, press enter, and one more. Nope, not that one. This guy right here. All right, and we're gonna do all of that and enter. All right, so these are my numbers. All right, all of us should basically have the same numbers. Make sure you're testing to make sure that yours is correct. Once you have that, you can scroll down. You're gonna leave your hypothesized value at 0. You can see your test statistic is the same one like we just calculated, 8.28. All right. In the right tail, it says rejected. All right. Upper tail p-value is basically 0. So now you can actually go in here and plug in all the information that they're asking for. So I'm just going to scroll over like one more. All right. Let me make this somewhat smaller so I can see it all. All right. And they're talking about what is the mean. What is the variance, sorry. What is the variance for machine 1? Variance for that first one, 4 decimal places, 0.0489. All right, once again, if you don't know how to do it manually within your head, you can click under home, go under the number, and move it over. Move it over 4 decimal places. All right, I'm just gonna do that first one. And then I'm also going to do my F test. All right, so 8.28. All right, check your work just to make sure you're good. Let's go, let's go, let's go, let's go. All right, so variance is pretty cool. Whether you're dealing with a 1 sample test or a 2 sample test, you plug them in. For the most part, it's a right tail test, and you can get your answers. All right, let's go to 11.27, please. Where did I see that one? All right, right here. So we're just going to make the assumption, two sample test. All right, 2.7. All right, we're going to say greater than in the alternative. All right. So this is interesting. So on 11, we're dealing with a two sample test. Actually, sorry, we're dealing with a one sample test. All right, here is my hypothesized value, 0.02. All right, so plug that in for your hypothesized value, 0.02, and then plug in all the other information that you have. All right, or less. You see, or less. Anyways, a sample of 41, plug it in. All right, a mean of a sample standard deviation, it doesn't give me my mean, a sample standard deviation of 0.16. Guys, you guys are gonna have to be able to convert from a sample standard deviation to a variance, because this is a test for variance. So 0.16 squared is 0.03. So based on a sample of 41, based on 0.03, we're comparing 0.03 to 0.02 using a sample of 41. Is it rejected or not? Yes, yes. So we're going to scroll down. We're going to see 51. When your F-test, especially if it's a right-tailed test, is bigger than, let's say, around 7 or 8, in your mind's eye, you should already know that it is in the rejection zone. Anyways, you can plug these numbers in. 51.2, check your work. All right. And you should be good to go. In this example right here, even though it's a big F value, it says do not reject. So give me a second here. All right. In this one, the reason why you do not reject is because the critical value is large based on the data that you've put in. And here's an example where it is not true. When this number is big, it's in the rejection zone. So this is why we calculate it and not just make assumptions. All right. The critical value is at 55.75. All right. So, and this one is at 51. So that's within the do not reject zone. So make sure you're checking your work. All right, just to get your answers. All right, that was a good example. All right, let's go over to 1131, please. I think that was the last one down here. Yes. All right, so this one here, you guys can plug in all the information, but automatically you can tell that this is a right, or this is actually a two-tailed test. All right, equals to, not equals to. What goes in the null or in the alternative hypothesis? Hopefully you're saying not equals to. If it's a two-tailed test, it is not equals to. And then make your calculations, plug in your data, all right, accordingly based on this, and then determine whether you're gonna reject or accept. I'm gonna let you guys figure this one out on your own. All right, how many more do we have? I believe we got 2 more. Let's go 1134, please, 11.34. All right, that was the first one. All right, so I'm just gonna make this a tad bit small. I'm gonna make this even more smaller. Please forgive me. All right, they're giving you all the information down here. Read this so you can get a good understanding of how this variance actually works. But just for time purposes, I'm just gonna plug in what I know. 31, sample variance is 23, cool. 26 and 11, cool. All right, so I got my variance. I got my variance, good. I got my sample, I got my sample, I got my standard deviation. My hypothesized value for a two sample test for the most part is 0. All right, and they're dealing with an alpha value of 0.1, 0.1. Ah, look at that. So instead of 0.01, you got to change this. So wouldn't that be 0.90, which is going to give you a 0.1? Make sure you're setting this up correctly. All right, then you can answer your questions. All right. So for the most part, like I said, this should be a right tail test. So I'm just going to go with that. In the alternative, I'm going to check my work just to make sure I'm on the right page. All right, it looks like it. Perfect. So what is, calculate the value of the test statistic. All right, so my test statistic is 2.09. Check my work. All right, and we should be good to go. All right, let's go to the last one, MC11-075. All right, that will be this one right here. All right, in practice, the most frequently encountered hypothesis test about a population variance is what? Hopefully you're saying, yo, man, it's a right tail test. All right, with a rejection zone in the upper tail. It's a one tail test with a rejection zone in the upper tail. All right, so a one tail test with a rejection zone in the upper tail. All right. So that is my tips and tricks within Excel when we're talking about hypothesis testing for variances. All right, it's either a one tail or a one sample variance test or a two sample variance test. But for the most part, most of our variances tests are a right tailed test only. All right, there are instances where you'll see two tail, there are instances where you'll see a left tail, but for the most part, it's a right tailed test. And it follows the same principles like we did for hypothesis test. Let's go, keep pushing and get that.